Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this MCQ series, in this video, we will discuss MCQs on the topic bending and shear stresses in beams of strength of material and mechanics of structure. Without wasting the time, let us start. Question number 1. Which of the following are the assumptions made in theory of simple bending? A. The material of the beam is homogeneous and isotropic. B. The beam is straight before loading and is of uniform cross section throughout. C. The beam material is stressed within its elastic limit and thus obeys Hooke's law. And D. All the above. Now, whatever given in option A, B, C, all are the assumptions made in theory of simple bending. Hence, the correct answer is D, all the above. Question number 2. For a rectangular section, the relation between maximum stress and average shear stress is A. Q max is equal to 2 times Q average. B. Q max is equal to Q average. C. Q max is equal to 1.5 times Q average. And D. None of the above. Now, for a rectangular section, maximum shear stress is always 1.5 times Q average. Hence, the correct option is C. Q max is equal to 1.5 times Q average. Question number 3. For a circular section, the relation between maximum shear stress and average shear stress is A. Q max is equal to 0.66 times Q average. Q max is equal to 1.33 times Q average. Q max is equal to 1.5 times Q average. And D. None of the above. Now, for a circular section, it is 33% greater than average stress. Hence, the correct answer here is B. Q max is equal to 1.33 times Q average. Question number 4. Name the axis about which the beam bends. Is A. Central axis. B. Parallel axis. C. Neutral axis. And D. None of the above. Now, any beam which bends due to any type of load, it is always about the neutral axis. Hence, the correct answer is C. Neutral axis. Question number 5. For a loaded beam, the bending stresses are maximum at A. Neutral axis. B. Topmost and bottommost layers. C. Topmost layer. D. Bottommost layer. Now, for a beam, the bending stresses are always maximum at extreme layers, that is top and bottom. Hence, the correct answer is B. Topmost and bottommost layers. Question number 6. For a loaded beam, the shearing stresses are maximum at A. Topmost and bottommost layers. B. Topmost layer. C. Neutral axis. And D. Bottommost layer. Now, shear stresses are always maximum at neutral axis. Hence, the correct answer is C. Neutral axis. Question number 7. For a loaded beam, the bending stresses and the shearing stresses are 0 at dash 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 respectively. A. Neutral axis and extreme layers. B. Extreme layers and neutral axis. C. Neutral axis and top layer. D. Bottom layer and neutral axis. Now, bending stresses are always 0 at neutral axis and shearing stresses are always 0 at extreme layer. Hence, the correct answer is A. Neutral axis and extreme layers. Question number 8. Structurally, the most suitable cross section for a beam is A. Rectangle. B. L section. C. T section. D. I section. Just in the previous question, we saw that bending stresses are always maximum at topmost and bottommost fibers, and shear stresses are always maximum at neutral axis. Therefore, flanges of I section resist bending stresses and wave of I section resist shear stresses. Hence, structurally most suitable cross section is I section. Hence, the correct answer is D, I section. Question number 9. For a simply supported beam carrying downward loads, the tension will be induced at A, top layer, B, central layer, C, bottom layer, and D, any other layer. For a simply supported beam, if all the loads are downward, the tension will always be induced at bottom layer. Hence, the correct answer is C, bottom layer. Question number 10. For a cantilever beam carrying downward loads, the tension will be induced at A, top layer, B, center layer, C, bottom layer, D, any other layer. Now, for cantilever beam, as it bends in hogging fashion, the tension will be developed at top. Hence, the correct answer of this question is A, top layer. Thank you.